Welcome, my dear students, to this another special video sessions for you for your geography class of class 10. Now, as usual, since we have started learning about the interpretations and the concept of contours and its applications. So, as the topic it is highlighted here, consider contours, contour lines and its applications. So, you have already have the common concept about this contour and all those three details. So I think there are some basic principles of contours you must have to keep in your mind. So these contour lines, while showing the height of different places on your survey map, it maintains certain properties, certain principles, and it never changes. Always it maintains that. So while learning and interpreting the topographical map, the basic principles of contours, you must have to learn, which will help you, and you have to keep always in your mind about those basic principles of contours. I think it is a very must, to have in you, so that you will keep it always in mind while studying the nature and spacing of contours and analyzing and answering, based on the question on the contour lines, on your survey maps, right? So as I have said, the contour lines are one of the basic, elements of this survey map, right? So details of it and a clear concept of it is very, very important to have, right? So today's class, I'd like to highlight, a little bit about the principles of contour, right? So as we have already started in your last class, I have already shown the details of different indicators of height and some this thing landform patterns based on the different contour spacing. So today I've decided to discuss about the principles of contours first. Then we will discuss about some other important aspects. Got my point? So let's learn about those basic principles of contours. So as I have said, principles of contour lines, right? What are those basic principles of contour lines? Clear? But what kind of the fix this thing it practices, what are the fixed property characteristics it maintains, and it never changes, right? Well, identifying the landforms, or the different patterns of this, slope aspects and all those things, it maintains certain principles, or certain rules, you can say. What are those? Now see, if you see the definition, if you try to think about what is contour, contour lines are the lines shown on the topographical map which joins the places of having equal height. So as I have said, these lines, what I have said, joins places of same height, isn't it? So this is maybe one of the basic principles, same height. Clear? And height measures from the sea level. So many dots are the spot heights of same height. Spot heights of same elevation, if it is shown. If you join with this, it will be a contour, right? With my point. So this is one principle, at least number one, right? Now spacing of contours. As I have said, closely spaced contours showing steep slope, widely spaced contours far apart from each other, brown lines, gentle slopes, you know it, right? So that means spacing of contour lines. I'm writing details lines what determines the pattern of landform. Pattern of landform, right? So it is closely spaced, steep slope, okay, widely spaced, far apart from each other, gentle slopes. So spacing is one of the basic, okay, you can say characteristics of the contour with which you can identify the different, okay, landform types or its angle of inclination of the slopes and other details. So these two are important, right? Number three, what, as I have said, okay, so for instance, the vertical height, elevation difference between two consecutive contours is what, 20 meter, okay, which remains fixed, okay. So what is that? The third major principle is contour interval, okay, like this V interval remains fixed, okay, in what is in topo map, right? In topo map, whatever, right? So contour interval, which is 20 meter in your survey maps, right? In your survey maps, in topo map it is supposed 20 meter and it will never change. If 20 meter is the contour interval, okay. So contour interval, it will not change. It remains fixed, right? So vertical height, okay, the height difference, okay, between two consecutive contours, okay, will remain same, and it determines, it is based on, okay, as per scale, it is determined by the scale, okay, and as per scale of the map, okay, whatever it is, right? According to scale, the height will change, okay. The contour interval always it remains same. In case of your survey map, which is of 20 meter, right? This 20 meter always of different 45 d by 7, d by 10, okay. Whatever type of the map is, the height difference, okay, vertical distance between two consecutive contours will be 20 meter. It will remain fixed, right? The scale is 2 to 1 kilometer or 1 to 50,000 is the scale of your survey maps, right? On that map, contour interval is 20 meter, which remains fixed. So 20, 20, 20, you have to go upslope ascending, and 20, 20 meter you have to come down while counting the contours towards the down valley, right? Okay, and that way you have to, okay, count the elevation or the, okay, angle of inclination of the height of different places. I hope you are getting things right. Okay, these are the basic principles. Along with that, one of the vital and most important thing about this contour, important principles of contour you can, okay, say, that is number one, okay. Okay, contour lines can never, okay, cross each other, cross or intersect, right? Each other. These contour lines cannot go like this. It can go parallel or close to it. Two contours can go close to it, but it will not go crisscross. But my point, so two contours can never crisscross like this. Okay, it can go parallel, it can go close to it, can even touch it also, coincide also, right? But it will never go like this. So this is wrong. It cannot go like this. You get my point? So what I have said out here in this details, okay, contours cannot crisscross each other, or it cannot intersect. Okay, that means it is wrong. Okay, never in any kind of topographical map. Okay, there are so many topographical maps. It is, okay, set in your books, but you can see nowhere, okay, two contours, two closely spaced contours are coincide and crossing each other. Okay, that cannot be, right? So height, it cannot be shown in that way. Okay, serially, consequently, you can go ascending and descending with the separate individual contours of 20 meters apart. Okay, so that's why the contour lines can never, okay, intersect or cross each other, right? Are you getting my point? Okay, they can merge, okay, they can merge and coincide each other. Okay, at the zone of coincidence over here, at the zone of coincidence, they can be like this, right? So all three contours, 1, 2, 3 contours are coinciding this point. This point indicates what? This point of vertical height. I will show you later on when they're showing the, okay, landform patterns with the, pattern spacing of contours. Okay, this is my at the point of merging each other. This is the fall. Okay, this is waterfall. Okay, that means gentle slope. Suddenly there is a breaking slope. Okay, to show the vertical height. Okay, or the very steep perpendicular vertical slope of the hill. It depends. Okay, suppose landslide, because of landslide, gentle suddenly there is a vertical slope. The causing of waterfall in geography class, you have learned those things. So what happened, to show the vertical slope of the mountain or that kind of angle of inclination which is 90° perpendicular, in that case contours can merge each other, but it will not cross one another. They can coincide in one point, showing the cliff means perpendicular 90° slope, but it cannot cross. As I have said, your number 4 principles. What is this? Okay, contour lines can never cross or intersect each other. Clear? So these are the basic principles that you have to keep in your mind always, so that while interpreting or analyzing or identifying the landforms, it will help you a lot. I hope you are getting it. So again, I repeat it again. So as I have said, this line join places of having same height. Okay, from the sea level actually. This height measured from what is it? From sea level. Okay, this height measured from sea level, right? Always height is measured from sea. We are coming on to it later on. Spacing of contour lines determines the pattern of the landform or the angle of the slope. Clear? So spacing of the contours will give you an exact idea about the undulations, angle of inclination of the slopes. Third, what is this? Contour interval remains fixed in topo map. Okay, in each and every categories of topo map, the intervals will be fixed, right? In earlier map it was 50 meter, current map 100 meter, but in recent available topo maps which you are going to face in your annual exam, ICSE exams, over there at the map 45D by 10, 45D by 7, over there contour interval will remain 20 meter, and that is fixed and considered as per the scale of 2 to 1 kilometer or 1:50,000. So interval remains fixed. Clear? The last and the final one, which is a very important one, the fourth principle actually, contour lines can never crisscross. It will never crisscross. It can come close to each other, even coincide each other, but it will not go crisscross like this. Clear? So what happens, that is the wrong concept. If it is so, never you will find though. Now see what happens, at the point of coinciding points, it can merge in one point, showing the vertical cliff. We'll have to discuss definitely about the cliff and other landform patterns. With what is the contour spacing of the cliff or the vertical slope, we'll discuss it in another session, right? So over here, what we're discussing, the principles of contours. So these 4 principles, along with other basic features of contours, that is a must to have, before you go to answer and identify the landform of the different, topo maps given. So this is what, dear students, you go through, and always keep in mind these 4 principles. That's very, very important. I hope you've got these concepts. So principles of contour lines, right? Very important. After this, I thought of giving you a special reminder about these things, about the principles of contours, because without these concepts, sometimes if you forget these concepts, it will create a complication for solving the answers, right? So a clear concept will be better. This theoretical knowledge always, if you keep in your mind, that will help you a lot, right? So the principles of contours will be there, will help you while solving the answers. Next is, say, after this, as we have discussed these principles of contours. So next things which I find is very important while solving the topographical map, means identification of landform, or you can say determination of landform. So my next, the topics or the points of discussion will be based on what? The determinations of landform with the available indications of height. Are you getting my point? So you see, in your classes, several times I have shown it too. What is it? So the subheading I'm just highlighting out here. Determinations of landform. You know, better to say different landform. Landform in topo maps. So, how to determine different landforms in topographics, right? So, yeah, you must have already some idea about how to identify the landforms, right? So, I mean to see how to categorize with the available indicators of height. Okay, which particular things will help you to identify the landform? So, contour lines, right? Spot heights. So, what are the indicators? As you know, indicators are, last class I have already discussed, indicators of height. If I see, what are the indicators? First, contour lines, you know. Second is what? Spot height, right? Third is what? Triangulation stations. Then what is it? BM and writing spot. Clear? Clear? These are the indicators of height. So with the help of these, when you go to identify the landform, there is a little bit of complication it arises, right? So up to which height it will be plane, up to certain height how to consider it will be a plateau, and what is the standard height of a hill or the mountain? There will be several values. 3-digit figures will be there behind any spot height, triangulation distance, all the contour values, right? So what happened to clear this concept? While finding so many contour points, if I show you in your book, you see I have one textbook with me. So see so many. If you see properly, got my point? There were so many contours. This is a portion of the highland area. Isolated hill. Now this is a flat yellow portions. Clear? Means to say which portion is flat, how to categorize which is a plain, what is the standard average height of the plains, plateau, hills and mountain. Got my points? So because values will be of several. We know values or the indicators of heights or elevation is contour lines, where specific contour lines, spot height, triangulation, so many things will be there. But what is the standard, standard, measurement of the height, standard value of the height of a particular, type of landform. Say for instance, a plain. What is the standard, average height of a plain? Plateau, hill. Got my point? So to standardize or to determine the different landforms with the available indicators of height, there will be so many height will be there. Got my points? Yeah. So that is why this concept is a must to have, right? So to solve this issue, to solve this problem or complications, so experts they have set a standard of this difference in height of different landform patterns. Got my points? So as I've said, height is measured from sea level, contour lines or spot heights or triangulation stations. So from sea level, the experts they have categorized and determined, they have fixed a certain average height of all types of landforms. I got my point, for plains, for plateaus, for hills, and for mountains also. You must have knowledge about these things. I used to show you in a regular basis in your geography classes. Now see, again I'm showing, since we are discussing it, and it is very, very special in your survey maps, because on a topographical map it will be very confusing. If you don't have the concept of differentiating about the average height of the plains, plateaus, mountains and hills, it will create a confusion. But up to which certain height from the sea level I will consider it is a plain. Up to what height it will be a plateau or the hill or the mountain. So this concept is a very, very, very important to know, right? So let's discuss diagrammatically. As you know, several times I used to draw up this diagram, so I'll try to show it once again to you. Okay, say for instance, clear? What I am showing, you must have some knowledge. The straight line shows the, what is this? Okay, SL. SL means what? Sea level, you know, right? Now I am trying to draw it this way. If I try to draw it 3D, got my point? I try to draw it 3D of it. Clear? Right? That means what? Let's consider this one, right? Clear? Are you getting it now? So this is sea level, water level of the sea. Clear? Whatever, sea level. I am trying to show you sea level. This is sea, right? So height is measured from where? From sea level. So if you start from sea level to measure the height, or you can say from this place, right? This place. Better to say. So in topography, you know, better I'll show you here only, right? So this is considered as a 0, isn't it? This from the sea level, water level of the sea, it will be considered as a 0. Height is measured from here. Suppose up to certain height, from 0 to 300 in meter, this will be what? So up to this place actually, this is what plains. What is it? Plains, right? That means what? All your survey maps, try to understand. I'm drawing this one. All your survey maps, so any spot heights, suppose this side, up to this area there will be several contours are there. Like this, so many contour spacings are there, got my point? Whatever it is, if this height, this contour is 220, 270, okay, 280, right? So this contours, okay, only there is no contours or less contours, right? Or any contour, this is suppose contour line, which values are suppose 230, this contour is 230, that means what? It's below 300. What I am writing, anything below 300, so that means this area will be considered as a what? Plain. Clear? So plain. Average height of the plain is 0 to 30 from the sea level. If it is flat leveling ground, you see so many contours. If contours value also will be ranging below 300, it will come under what is it there? Plains. Right? So now you see. Okay, the contour value or the contour value of the spot height or the triangulation station or benchmark, if it comes within 3 to 6, within 3 to 600 meter, this will come under plateau. This will come under what? Plateau, right? If you get a clear view, okay, as I am showing out here, so this ranging, it was set, okay? This particular classification or categorization of different landforms and its average height, it is set by some experts of geographers. Okay, so experts in geography, whatever that they have, to clear the confusions, which will be the certain standard height of plains, plateaus, and hills, they have categorized this way. Measured from sea level to 300 is plains, 3 to 600 is plateau. Right? Suppose this particular area, right? This particular area. Right, the contour spacing are the out here, say for instance, 550. Got my points? This is a gently sloping area. Okay, 550. The spot height is given, not triangulation station. Right, 550. Okay, then this one, say for instance, out here, 420 or 450, whatever. Okay, it comes under what is this? Plateau. Clear? So this will help you to identify different types of landform based on the figures and values of those spot heights, contour lines, and those triangular solutions. So beyond 600, anything beyond 6 and 900 meter, this will come under hills. This will come under hill. Got my point? So hill will be like, suppose this is an isolated hill out here. I have drawn a circular contour patterns like this. Okay, isolated hill. Suppose it is the spot height given out here 720, whatever it is. Okay, 720, which is beyond 600, it will not be considered as a plateau. This part is plateau, this part is hill. It is quite ascending on up. That means contour spacing is encircling. Okay, the concentric contours showing up, and the top value over here, suppose one triangulation station is given and value marked over there 720, so it comes under hill, right? So this area will be hill. Got my point? Okay, some other mountainous area or other areas, suppose out here. Got my points? Out here, say for instance, the closely spaced contours. So many closely spaced contours are there. Very close to each other. Suppose out here, top of the mountain, it is suppose 1100. Okay, 1100. The value over here mark how much? 1100. Clear? Of this close to this contour. That means this is also highland, but as per the value, okay, it's mentioned out here, which is higher than this hill. It is 720. This is also highland. This is also highland, showing close to spaced contours and okay. And circle towards the center of the circle, and it is the value marked 1100. Okay, so 1100 means anything beyond 900 still comes under mountain. Mountain. So top of the mountain. Suppose okay, anything okay. This is suppose this is Mount Everest. What is the height of Mount Everest? 8,848 meters. Okay. I'm showing top of the crest of the mountain. So anything above 900 meter, okay, will not be considered as the hill. That will come under mountain. Clear? I hope it is clear to you. Again, I repeat you. Okay, so on your survey map, based on the contour specific and the value or the indicators of height, okay, maybe spot heights or the contour value, okay, all the triangulation stations, wherever it will be marked over there in the survey maps. Okay, how to categorize different types of landform, okay, based on those available okay, signs and symbols showing the height, right? So the geographers, they have set a fixed standard, okay, height, average height of certain okay landforms. For plains, certain standard set of height they have mentioned. There is 0 to 300 meter, okay. For plateau, 3 to 600 meter. There will be higher plateau than 600 also. That will be exceptional, like Palmy Plateau and other. Okay, that's quite higher, like a mountainous area. It is depending on the size of the okay landform pattern. But average height, okay, on your survey maps to categorize it, this will help you a lot. So this diagram, okay, will help you to identify the landform patterns. Very common question. What type of landform, okay, in this particular grid reference? That will be your questions, okay. So over there, the available contour value or the spot heights or anything which shows the height of the area, if it is ranging 200, 250, it will be plain. It will be 500, 530, it will be okay, a rugged plateau or something. If it will be average, going below, beyond 600, it will be hill. As I have said, 6 to 900 hill. So this diagram, okay, the concept of this determination of different landforms with the available okay symbols of height, okay, is very, very important, right? Clear? So that's why I have okay, I thought of giving you a special sessions about this particular issue, right? So with the available survey maps, okay, and whatever the okay existing number of okay this thing elevations or height, it will be shown by the spot heights. Okay, triangulations and contour values will be there. So you can categorize those with this standard okay average height of landforms, and you can identify the type of okay particular landform on that particular very space where the question is based. Okay, the question is made and asked. It's clear to you. So this is okay very, very important. You must have this knowledge with you okay before you go to okay solve the okay this topographical map of 20 marks. I hope it is clear to you, right? I don't have to repeat it again. Understand? So these are the average standard height of different landforms. So with those value only, you have to categorize all your survey maps to identify the different landform patterns. Clear? Okay, so whenever you practice to okay, answer that question, what type of landform in this particular portion of the map, the grid reference will be given. Okay, so with the available, okay, values of spot heights and contour values and the triangulation distance, you have to identify the landform pattern of that. Clear? Okay. So go for it, you will learn it clearly. So this is what very important, as I've said, determinations of landform patterns, and these are the average standard height set, okay, fixed by some experts in geography. So I hope it is clear to you. Now, let's discuss some other basic points. Very simple things I would like to highlight in this very class. This was my main this thing target today. Okay, to show you the details about this standard height of different places, right? Now, I would like to conclude this class while showing a certain very interesting fact about this. I can say the difference in spacing of contours and two different interesting figures also, how it comes out about the outline of landform, right? Say for instance, okay, you have already learned about the spacing of contours, and I hope you have that concept also to show the a cross section, to draw the cross section. So okay, with the available pattern of spacing of contours and what will be the outline, I believe you know the method how to draw the cross section, right? I'll give my point. So if I try to show you two different interesting, okay, spacing of contours and its, okay, outline of the landform, how it comes. Let's learn. So it will clear your concept about the spacing of contours and alignment of the contour, because you know, okay, on your topographical map, you see this map. Can you identify the, okay, this thing, can anyone identify the landform pattern out here? You must have that common concept of studying the nature and spacing of contours, then only you can identify the landform over here. So that is where, okay, the spacing of contours, the alignment of contours will help you to identify whether it's a hill, is a spar, is a valley, okay, is a steep slopes or is a gentle slope or whatever. Okay. So I'll give you certain other, okay, some interesting, okay, spacing contours and its, okay, outline of landform. Let's discuss about the, see, an isolated highland, say for instance. Isolated, what is highland, right? I'm trying to draw it here, isolated highland. What will be the, okay, this thing, isolated highlands, contour patterns. You know it, very simple, okay. Suppose if I try to draw it like this, right? Suppose this is the top portions over here. Suppose this it is 720. Okay, this is suppose 600, 500. This is 400, 100 ever. Okay, this is suppose it is, okay, 200. Got my points? So these are the, okay, from that means what value indicates from outside it is going towards value increases towards in, that we are showing the upslope. Okay, is a circular means it is all around, okay, on the circle way it goes up, it's showing the mound. Got my point? So what happens if you try to draw a cross section of this particular thing? Once again, the largest one, how many 1, 2, 3, 4, 5 lines? You draw the, okay, graphs ready to get the outline of this particular thing. Try to understand. I think it's enough. Say, what is it? Highest is 700. Or let's consider 700 only. Then 6, 5, 4, 3, and 200. 100 is not given. Anyway, so what happened? I try to coincide while this with this cross section, contours should be coinciding, okay, crossing twice. So come up to 300. Then out here 400. So to get the outline, I believe you know this, okay, way of getting the outline from the pattern of contours. Then again it is decreasing towards left. I'll give a point. So it is 300. Yes, 200 points are in here. Now see, now you have got this particular shape of the land. Okay, it's just going towards the up. So this will be there in your survey maps. Clear? And you have to get this this thing. You don't have to draw every time, right? You have to guess and identify with the spacing of contours. You have to guess the points. You have to get the impressions with the available spacing and alignment of the contours. What I'm going to show you. So if the concentric circular contours, which is value increases towards the center, from outside towards the center, value increases towards the center, it's considered highland. Okay, isolated hill or mountain, whatever, depending on the value. Mountain means anything beyond 900 meter. Okay, since it's 700 meter, okay, this will range within the hill. Okay, this isolated hill or highland, right? Now exactly. My purpose to show not this outline exactly, but to show another interesting fact. Okay, this is isolated highland I have drawn, or the isolated hill. Okay. Now on the other hand, now I am just changing the pattern of the values. You see what it comes. Suppose same pattern of contour. Yeah. Now see. Suppose the pattern of contours is almost same, right? Now this time instead of value increases towards the center of the circular contour patterns, let's consider this one 700. So value decreases towards the center. I mean to say 500, 400, 300, and this is suppose 200. I'll put a point. Now this time value, it decreases towards the center, or it increases from the center and outward, which is not the case out here. Very interesting. Argument point. So value, it is increasing of the concentric circular spacing of contours. Value increases towards the center, so it is hill, top of the mountain, right? Now what happens out here? Exactly opposite to this. See the contour spacing. So value decreases towards the center of the concentric circular contour lines. Okay, rather it increases outward. Clear? Now get the thing over here, cross section of this particular thing. Clear? Now how many are there? So get the lines to roughly, right, with my free hand. Drawing straight lines will be not easy. Whatever. So now the value is what? 700 is the highest one. 600, 500, 200. Up to 200 it is shown here. Now see, coinciding all those 2 points which is crossed with this section line. Now, so start from the middle. It should be vertically. You have to come down up to 200. Argument point. So again, suppose this one, then 300, go up to 300 on either side as the pattern of the spacing of contours. Next, suppose this is 400, come up to 400. This side even. Clear? Now next is 500. Try to understand. 600. Over there also you come up to 600. And 700 coincide here, right? So now if you try to join all those coinciding points with the horizontal lines, as you have drawn it vertically, but more point these coinciding points you have gone vertically down to get the exact outline, see the shape exactly. Now the shape, it has come like this. To be like this actually. So exactly opposite, have you noticed or not? It's a difference. It's a lake. I'll draw a point or the valley. You can see. So if it is a circle, it will be a lake. Actually, the actual thing will be like this. So like a circular pond. So it will be a lake. The contour pattern of this thing will be, say for instance, it's a lake. Say for instance. Lake or depression, better to say. depressions, okay, low-lying basin-like reserve, okay, it's a basin, better to say. Basin, okay, whereas this one is a mound, okay, it will be like this, mound, okay, got my points? So, compared to the flat area, for example, this is a mound, okay, a pile or the heap of the sands or the, okay, landform patterns, okay, as a mountain. So, what I mean to, okay, point out here particularly on this particular, okay, this two diagram, okay, you have to be very careful while, okay, studying, okay, the value of the contours, which is very important, okay. Pattern may be same, the contour patterns are same. So see the value I have changed and see the, okay, two dramatic changes in the outline of the landform. I got my point. So always go through the value, okay, try to understand, and the spacing also, okay, and the spacing of the contours, that will help you to identify the exact nature of the landform. That is what, okay, I wanted to show you out the difference between the highland, okay, or the isolated highlands or the circular contour patterns. These are also circular contour patterns, but value changes, it decreases toward the center or increases outward of that concentric circular contours. So it becomes a lake, it becomes a depression area, okay, a basin like reserve. So, but out here, okay, which is not the case, value increases towards the, okay, concentric circular contour patterns, right? This shows the elevation of the place. From surrounding area, it slowly going up like a hill normally, right? So this is going to hill. Clear? So many interesting, okay, the landform patterns with the, okay, given contour spacing, okay, you have to identify, right? I find it very interesting. Definitely, it is very interesting. What you have to do, simply you have to, okay, be attentive while learning it, right? So my suggestions will be, you go through the video, okay, watch it repeatedly. There are so many examples of contour spacing and contour patterns, and its, okay, associated landform. It is drawn with several cross sections in your textbook of geography of class 10. So you go through all those, try to identify before you actually try to answer, to identify the landform on your real topographical map. So before you go to answer and find out the different landform patterns on your topographical map, okay, this knowledge you are supposed to have it, okay, this is priority. Otherwise, okay, learning and directly, okay, interpreting and answering all those questions, it will be quite, not scientific at all, okay, it's not a wise, okay, steps. So better you go through all those things. So this, I hope and I believe these videos will definitely help you a lot, right? So with this, I like to conclude this class today. As I've said, the, okay, determinations of the different landform patterns with the available symbols of the in height. With my points, plains, plateaus, hills and mountains already I have discussed in the earlier diagram, right? Before that, the principles of the contours, right? It cannot coincide with each other, right? Contour interspacing is 20 meters, all I have discussed. And finally, okay, the interesting diagram, okay, based on the, okay, value of the contours. Okay, the value of contours, how dramatically or drastically changes the appearance of the, okay, landform. Clear? Hope you have found it interesting. So I'll, okay, suggest you to go through the book and watch these videos to gain the concept right? So I'd like to conclude with this. So I'll come again with some other important facts and figures and, okay, the explanations of your, okay, interpretation of topographical map, this particular first chapter. Okay. So take care and go through this. Hopefully it will work for you. Okay. So see you next, and thanks for watching.